Hello everyone. Thank you so much for watching this Chapter 4 test review video. I only got a couple of requests for specific problems that people wanted to see me do, so I decided to give you the general information here about the test, a couple of hints and reminders if you watch closely, and then I chose a couple of problems that I think would be good to work through. So first and foremost, all the details about the test. It is 60 total points. 30 of those are with the calculator and 30 of those are without the calculator. You do get the full 50 minutes and you can split that up however you like. I would say most of you will probably want to split it up about equally. You're going to do the no calculator part first, and once you turn that part in, you can't have it back. The calculator section, you're going to start off in degree mode. Make sure that you round to 3 decimal places always, like we've been doing, unless otherwise noted. And again, otherwise noted might say leave it in terms of pi or leave it as a radical, but otherwise you're going to go ahead and round to 3 decimal places. I would say that those of you who really truly know the content well are probably going to find the no calculator part easy and perhaps faster. Those of you who kind of have to draw triangles and draw things for every single problem might struggle a little bit. As always, you want to be mindful of your time, and I will remind you throughout. So as promised, you are going to be getting all of the formulas, or at least all the formulas that I show you here on the sheet. So you're going to get the formulas here exactly as is. It's the exact same copy. It wouldn't be the worst idea in the world for you to take the first 2 or 3 minutes of your test tomorrow, writing down as much as you think you might need on this formula sheet, things like triangles and ordered pairs and ratios and reminders. If you spend 2 or 3 minutes writing them down once, it will save you time on the back end that you won't have to calculate every single time. So again, here are some things you might want to add in. You might want to add in for yourself that this is the law of sines. You might want to also remind yourself that you should use the law of sines whenever you have angle, angle, side, angle, side, angle, or whenever, of course, you have side, side angle. That is the ambiguous case, which we're going to talk more about in a few minutes. Then you might also want to indicate that everything in both of these 2 boxes here, this is all the law of cosines. Everything in the middle here is what would happen if you were solving for missing sides compared to solving for missing angles. Remember, you could technically use the side formulas to find angles and vice versa, but this is just kind of an easy way to separate the 2. You might further want to remind yourself that you would use the law of cosines whenever you had side, 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 or side, angle, side. Other kind of word problem, formulaic things that you might need to know. These are your 3 area formulas. You would use the first one if you know the base and the height of a triangle, or if it's very, very easy to find. You would use the second one if you knew the 3 sides, A, B, C, of the triangle. Remember that for that formula, S is the semi-perimeter, which means you would have to first add up the 3 sides and then divide by 2. Finally, if you knew a triangle of 2 consecutive sides and the angle between them, you would go ahead and do 1/2 their product times the sine of that angle. Over here on the left-hand side, these, of course, only work in radian mode. So for anything that is in degrees, you have to first go ahead and convert it. This S equals R theta. Remember that that is arc length. Remember that W equals theta over T. This is your angular speed. How fast is the angle turning? Followed by your linear speed. How much distance is covered over a certain time frame. And then this last one is the area of a sector. I would also point out here that for the linear speed formula, you can rewrite this in several different iterations. If you were to take the S and rewrite it as R theta, this is one version of the formula that might be helpful. If you then further realize that this theta over this T is really equal to W, you could further say that V was equal to R times W. So again, I'm only giving you exactly what is here. So if you feel like you need to write anything that I've just added in for yourself tomorrow, please feel free to do that. And in case I didn't say it already, you are going to be able to use this formula sheet for both parts of the test. So whatever you write at the beginning, you're going to have for the entire time. While I 100% do not think that you should fill in the entire unit circle, some people did request it, so I did give you a blank one just in case. Again, just be careful. The more time you spend here at the beginning writing stuff down, it is time that you're going to lose at the end. So I do think a few minutes is worthwhile. Anything more than just a few, I think might not be worthwhile. But other things you might want to remind yourself, this is of course quadrant 1. Remember, in quadrant 1, it's a positive positive. In quadrant 2, it's a negative positive. In quadrant 3, it's a double negative. And here in quadrant 4, it's a positive negative. I'm not suggesting you should be writing all of this down tomorrow on the formula sheet, but again, since I'm here reviewing, I figured it couldn't hurt. You might also want to remember the all students take calculus. Remember, that is meant to assist you in remembering where things are positive for all the 4 quadrants of the unit circle. I would suggest that you do write in a couple of things. If it was me, I would probably draw in the 4 ordered pairs of the quadrantals. Remember, those ordered pairs are exactly where they are because the length of the unit circle radius is always 1. Remember, even if you are not on the unit circle per se, on any circle, R always has to be positive. So please make sure that you remember that. After you've gone ahead and written in the quadrantals, you probably want to think about the 30, the 45, the 60, and of course that's pi over 6, pi over 4, and pi over 3 respectively. It might be a good idea to go ahead and write in those ordered pairs. Square root of 3 over 2, 1/2. Square root of 2 over 2, square root of 2 over 2. That would be this one. And then 1/2 square root of 3 over 2. Not only might you want to consider writing in those first quadrant ordered pairs, but as I had suggested several times in class over the last few days, you might also want to consider writing in the tangents. Again, every trig function, no matter which one I give you, can always be rewritten easily as a sine, a cosine, or a tangent. So if you remember that, of course, the x's represent the cosines and the y's represent the sines, the tangents are the sines over the cosines or the y's over the x's. If you can remember that, then they're always going to be easy to write sine, cosine, or tangent. And if you can always go back to those big 3, I think it will make life easier. So over here at 1, 0, if you were to find the tangent, 0 over 1, you would get 0. 1/2 divided by radical 3 over 2, that would cancel to be 1 over radical 3, which you would then rationalize to be radical 3 over 3. Here at square root of 2 over 2, square root of 2 over 2, anything over itself, of course, simplifies to be 1. And then up here at pi over 3, the square root of 3 over 2 over 1/2, the 2's would cancel. And then up at the top here, it would, of course, be undefined. So again, not saying that you should write all of this in tomorrow, but while I'm here, I figured I would mention a couple of things just to kind of give you some reminders. So this is just an idea of what you could potentially write, as well as some additional practice problems, and then you can go ahead and do with it what you will. Again, remember that the whole point of this circle goes back to the reference angles. For example, the pi over 6, if you were to go ahead and drop a perpendicular there, and then you were to go over here to the pi over 6 in quadrant 2, which is, of course, 5 pi over 6, they would have the same exact reference angle here from the origin. Same story if you go to 7 pi over 6, and, of course, if you go down here to 11 pi over 6. They all have the same reference angles. They all have the same ordered pair, except, of course, for the positives and the negatives. So that means that the functions repeat. And again, if you understand that, I think that it should make a lot of sense. So a couple other things. Speaking of those specific values from the unit circle, definitely not something you are expected to memorize here. But while I think that the majority of you are probably pretty comfortable with the sines and cosines, again, take a look. All you see here are 1s, 0s, 1/2s, radical 2 over 2's, and radical 3 over 2's. The tangent is what I just went over. The more times you calculate those tangents, the more familiar they become. So these were the 3 that we just did in the first quadrant. And then, of course, notice as you look down the column, it is the same exact values except for the positivity and the negativity. That is the whole point of a reference angle. They always have to have the same answers except for possibly the plus or minus. The final 3, the cotangent, the secant, and the cosecant, It might not be a bad idea to look at these values so that they seem familiar, but at the end of the day, I would recommend for anything on the unit circle, rewrite your cotangent as a tangent, your secant as a cosine, and a cosecant as a sine. And of course, you would do that by doing 1 over. This is good practice, not just for evaluating on the unit circle, but also off the unit circle when you need the calculator, specifically because you only have a sine, a cosine, and a tangent. You don't have any of the other three. So this section here, again, nobody requested it, but I just do want to say how valuable I think this section is, not just because you're probably going to see a few of these tomorrow, which I think you are, but these kind of theoretical questions are really just great. They show me whether or not you really understand the material. And again, that is kind of what I'm going for tomorrow. I really do like this test. I think it is comprehensive. I would not describe it as hard, but I would describe it as comprehensive. So again, those of you who have been faithfully doing your homework and doing the lessons every night that I assign them, I think you're going to do great. Those of you who kind of tried to shove it all in at the last minute might not be so successful. I mentioned this to one of my periods today, but let me just again reiterate. The test has a lot of very short questions, like a question that might take you 30 seconds or less to answer. I might say to you something like, the cosine of 140, is that positive or negative? For you to answer that question, you would have to know that 140 is, of course, in quadrant 2. You would have to know that a cosine is an x value, and then x values in quadrant 2 are negative. I could say to you, in quadrant 3, the signs are blank, and you would fill in positive or negative. That's the same thing, sorry. But this idea of like a simple, quick question where you're just filling in an answer, filling in a blank, doing a very easy multiple choice. There are quite a few of those tomorrow. Again, very just quick. Do you know this fact about the unit circle or not? Do you know what the reference angle is? Do you know what the ratio is? Do you know the positive or the negative is? So expect to see a couple of those quick questions, which again should only take you 30 seconds, maybe a minute. And then you'll see some extended questions as well with multiple parts, more like those open-ended questions for the AP test that we've been talking about this whole time. Again, nobody really suggested that I do these questions, and since there aren't a ton of them, I do want to leave those for you, but I do want to reiterate that I think that they're great questions. So make of that what you will. I chose one multiple choice here because there will be a few multiple choice tomorrow, as always, but again, I just think it's a great question. So find the point xy on the unit circle that corresponds to theta equals negative 2 pi over 3. That is, of course, a radian measurement. I know that you are not as familiar with radians as you are with degrees. If this was the calculator part of the test, you could convert. If you didn't have a calculator, you could try to convert, but it might not be successful depending on how large the value is. So again, the more familiar you are with radians, the better off you're going to be. In addition to not loving radians, I get that you might not love the fact that this is negative. So remember, every time you have a value, no matter what the question is, if it's larger than 1 revolution or negative, you can always try to find a coterminal angle. To find a coterminal angle in degrees, of course, you add or subtract 360. To find it in radians, you add or subtract 2 pi. In this case, 2 pi is equivalent to 6 pi over 3. So here, you could go ahead and rewrite the angle as 4 pi over 3 if you go ahead and add 6 pi over 3 to it. Now, just to be clear, negative 2 pi over 3 and 4 pi over 3, those are not the same angle. They are not equal. A smaller negative angle is clearly not equal to a larger positive one, but they are in fact coterminal, which means they end at the same spot. If they end at the same spot, they have the same exact ordered pair, which means they have the same exact sign, cosine, tangent, and all 6 trig functions. So now that I know that I'm looking at 4 pi over 3, everything that's pi over 3 has a reference angle of pi over 3. So again, anybody in the 4 pi over 3 family or anybody in the pi over 3 family is always pi over 3. Everybody in the pi over 4 family has a reference angle of pi over 4, and everybody in the pi over 6 family has a reference angle of pi over 6. So that should make things easy. If I think about pi over 3 in the first quadrant, I would, of course, hopefully have written that ordered pair down on my sheet. I would, of course, know that that's 1/2, comma, radical 3 over 2. This is true in quadrant 1. I am being asked about 4 pi over 3, which hopefully you know that 4 pi over 3 is in quadrant 3. In quadrant 3, x's are negative and y's are negative. So you are looking for the equivalent of this ordered pair, but it has to be a double negative. So that would, of course, give you choice C. And again, some of you might not need to write anything down. It might be pretty clear and obvious to you, but if you did have to write anything down, this is kind of what you should be thinking about. How about something like 27? So use the given function to find the requested trig value and then assume the angle lies in quadrant 1. Now, this would be a very easy version of the question where I show you and tell you straight out what quadrant you are in. If I don't tell you what quadrant that you're in, I would have to give you some additional piece of information. Right here, I know that the tangent is in fact positive. So the fact that the tangent is positive means it only could have been quadrant 1 or quadrant 3. And then again, here specifically, I am telling you. So remember, each piece of information always cuts your choices down by a half. Something else that's really important to note here is that when I tell you that the tangent of theta is equal to 4, I'm really telling you 4 over 1. So don't forget to add that 1 in. So 4 over 1 is equal to y over x. The fact that I'm in the 4th quadrant, if you go ahead and think about your triangle, you have a positive 4, a positive 1. You would go ahead and find the radius by doing 1 squared plus 4 squared equals r squared. 17 equals r squared. Take the square root. Normally it's plus or minus, but of course the radius is always positive. The square root of 17 does not simplify. If it did, you would, but it doesn't, so leave it. So the easiest thing for you to find now is the cotangent. No work required at all. It is the reciprocal of the tangent, which means it is 1/4. So now moving on to the secant, you would of course have to know that the ratio of the secant is equal to r over x. It is the reciprocal of the cosine. So you're going to get the square root of 17 over 1. You could put the 1 or not. It's up to you. Finally, the sine, the ratio of the sine is equal to y over r. That would be 4 over the square root of 17, which you would write as 4 radical 17 over 17. Notice that in quadrant 1, everybody is positive, as they should be. This little bonus question here, what would be different if this was a quadrant 3 angle? If this was a quadrant 3 angle, instead of the tangent being equal to 4 over 1, it would have to be equal to negative 4 over negative 1. Then what other values would change? Well, in the 3rd quadrant, the cotangent would still be positive, but the secant would be negative and the sine would be negative. All the values would be the same. The triangle would be congruent. The only differences would be the signage. Moving on to the last couple questions here. Law of sines and cosines, there is very few of those on the test tomorrow. 1, because they can take a long time to solve, and 2, because we already saw some on our most recent quiz. Here, I think the person who requested it mostly was unsure about the angle, so let me go ahead and help set that up. Again, notice there was one small change. I just typed it incorrectly, so I did tell you during class, but just in case you missed it. So looking at the fact that one of the angles is north 50 degrees east, that means you're facing the north and then turn 50 degrees to the east. The second angle, south 70 degrees east, means you're facing the south and you turn 70 degrees to the east. If I know those 2 angles, I can actually find this angle here because those 3 angles together have to equal 180. They make a straight line. You could think of it as supplementary linear pairs. That's usually just for 2, but all of them have to add up to 180, which means this has to be 60 degrees. Then additionally, you know how fast each of the boat is driving, and they tell you that this is going on for 3 hours. So the first boat, 90 miles per hour is the total, or 90 miles is the total distance because 3 hours times 30. This second piece here is 26 times 3. So 26 times 3 will give you a value of 78. Now that you were able to find those 2 sides, they're asking you to find how far apart the boats are. So you are looking to find this 3rd side here. I'm going to call that X. You can call it whatever you like. If you take a look at the information that is given, you have a side, you have an angle, and you have a side. That is side, angle, side. Side, angle, side is, of course, law of cosines. I'm going to leave you to finish it, or you can look at the full answer key, but I imagine that the person that asked just kind of wanted to see the setup. The last thing that I want to talk about, a few people asked about, was the ambiguous case. Now, again, you are unlikely to see, definitely will not see more than one question on this. And again, you might see none or just one. I'm not exactly sure where the disconnect is for these problems. I don't think it's a matter of actually solving it. Maybe it's a matter of when to check and how to check. So I will reiterate that one more time. Just to be 100% clear, you only have to check these for non-word problems. You only have to check them when you're using the law of sines, never the law of cosines. Finally, you only have to check them when it is specifically side-side angle. There can be no solution, there can be one solution, there can be two solutions. So for both of these, I have drawn a triangle. Let's go ahead and put the indicated information. So little b is 10, little c is 6, and then angle C is 33. Over here on the right, little c is 10, little a is 8, and then c here is 64 degrees. Please understand that this is a side followed by a side followed by an angle. This is a side followed by a side followed by an angle. So that is why they are both side, side, angle. Those are the only ones that you even have to check. So how do you check? Well, in both of these instances, there's only ever going to be one thing that you're allowed to solve for. Remember that the law of sines involves knowing a matching set of angles and a matching set of sides. So this fact here, I know that 6 over the sine of 33. If the only other piece of information that I know is 10, then the only angle I'm able to solve for would be B. Let's go over and look at the one on the right as well. Because of the fact that I can only solve for what I have a matching pair of, I know that 10 over the sine of 64 is going to be equal to 8. And then the only thing I'm able to find is angle A. So go ahead and do your setup, which at this point hopefully is easy. You're then going to cross multiply and divide. And again, please make sure you're in degree mode. Again, you should start off in degree mode tomorrow and then only change it if something says radians. If you're doing these practice problems tonight at home, please make sure that you are in degree mode. Sorry, just need a sip of water. So now from here, you're going to go ahead and cross multiply and then divide. So the sine of B is going to be equal to 10 sine of 33 over 6. You will then need to do the inverse sine in order to get angle B by itself. If you go ahead and do that, you're going to get B equals 65.194. Really no different than we had done earlier in the chapter, solving for a missing angle. Let's look over here. If you go ahead and cross multiply and divide, you're going to get 8 sine of 64 divided by 10. You're going to go ahead and take the inverse. That is going to tell you that angle A is equal to 45.975 degrees. So again, this is the only angle you had enough information to solve for. And now that you have found that first angle, here is where you need to check. So let's check the left-hand side first. So you're going to take this angle and you're going to ask yourself, is there a second triangle? Now, just to be clear, we know, in fact, that each of these has at least one solution because we found it. If either of them said domain error, we would know that it was no solution and the problem would be over. So now that we found at least one answer, let's see if there's a second one. So if there's a second triangle, that means that angle B could be the supplement. So 180 minus 65.194 means 114.806 would be the potential second triangle. The way that you check that is by adding that angle to the original given angle. So the original given angle in the problem was 33 degrees. So you're going to add that to 33 degrees. You're going to get 147.806. you are going to check, is that less than 180? If the answer is yes, it means that there is a second triangle. And again, what does it mean that there's a second triangle? It means that if you were to redraw this triangle, you would have to redraw a version so that angle B was obtuse as opposed to being acute in the picture that I gave you here. Remember, when we draw our triangles, we're just sketching them, so they're not necessarily to scale. So there is a second version of this triangle that exists that has an obtuse B. So now that I know that there are, in fact, two solutions, you're going to finish solving with this B, and then you're going to finish solving with this B. And again, I would imagine that most of you probably can do that part. Maybe it's just a matter of checking. But again, the conclusion here was, yes, there is a second triangle. Over here in the other example, we had found angle A, which was, again, the only thing that I was able to find given the information. Ask yourself, is there a second triangle? If there were, it would have to be the supplement. So 180 minus 45.975, that is going to give you 134.025 degrees. In order to check, you're going to add that to the original angle, which was 64. You can kind of tell already that it's going to be bigger than 180. In fact, it's 198.025 exactly. That is, in fact, greater than 180, so no second triangle. So again, I'm not exactly sure what the disconnect is. I don't know if people don't know how to check or don't know when to check, but hopefully that helped to clear things up. So I do think that there were some kind of hints in this review video for tomorrow. And all I'll say is, again, I really do like the test. I think that it is certainly comprehensive. So make sure that you go back to the top here, make sure you know exactly what is expected of you, make sure you know the format. And again, this is the review sheet. So take a few, or the, formula sheet. So make sure you take a few minutes to know where everything is located and think to yourself, what kinds of things might I want to write for myself? Practice them tonight, and hopefully all will go well tomorrow. So thanks so much for tuning in, guys. Good luck, and I will see you tomorrow.